Several factors can cause an air conditioning unit's breaker to trip, and it's important to systematically investigate each possibility. The first potential cause is an overload. The air conditioning unit might be drawing excessive current, which forces the breaker to trip. This situation can arise if the air conditioning unit is undersized for the space it's cooling, is heavily loaded due to high demand, or has an internal component that's malfunctioning and drawing more current than it should. Secondly, a short circuit could be the culprit. A short circuit occurs when live wires inadvertently come into contact with each other. This creates a direct, low-resistance path for current to flow, leading to a rapid surge in current that trips the breaker as a safety measure. Damaged wiring, loose connections within the air conditioning unit or its wiring, or a fault within the air conditioning unit itself can all cause a short circuit. Thirdly, a ground fault could be the reason for the tripping breaker. A ground fault happens when current leaks from a live wire to ground, meaning it's taking an unintended path back to the electrical source. This leakage can be caused by insulation damage in the wires, loose connections that allow current to stray, or a defect within the air conditioning unit that allows current to leak to its grounded metal chassis. Fourthly, an arc fault could be responsible. An arc fault is an unintended electrical discharge that occurs when electricity jumps between 2 points, creating a spark or arc. This arcing can generate intense heat and can potentially start a fire. Arc fault circuit interrupters, or of size, are designed to detect these arcs and trip the breaker to prevent fires. Damaged wiring, corroded connections, or loose terminals can all lead to arc faults. Finally, loose connections in the wiring can also cause a breaker to trip. Loose connections increase resistance to current flow, generating heat at the point of the loose connection. This heat can eventually damage the wiring and the breaker itself, and it can also cause the breaker to trip as a safety precaution. To troubleshoot the issue, you should first inspect the air conditioning unit thoroughly. Look for any obvious signs of damage, such as burned wiring, loose connections, or physical damage to the unit itself. Make sure that the air conditioning unit is properly sized for the space it's intended to cool. An undersized unit will have to work harder and draw more current, potentially causing an overload. Next, test the breaker itself to ensure it's functioning correctly. You can use a multimeter to check the breaker's continuity and its ability to trip under a test load. If the breaker is faulty, it may trip even when there's no actual problem in the air conditioning unit or its wiring. After that, carefully check the wiring that connects to the air conditioning unit. Look for any signs of damage, such as frayed insulation, cracks, or exposed wires. Ensure that all connections are tight and secure. Loose connections can cause resistance and heat, leading to a trip breaker. Then, measure the current draw of the air conditioning unit while it's running. Use a clamp meter to measure the current on each of the wires feeding the air conditioning unit. Compare the measured current to the rated current of the air conditioning unit, which should be listed on its nameplate. If the measured current exceeds the rated current, the air conditioning unit is likely overloaded. Lastly, if necessary, isolate the air conditioning unit from the circuit and test it separately. This involves disconnecting the air conditioning unit from its power source and using a separate power source to test its operation. If the air conditioning unit trips the breaker on the separate power source, then the problem is likely within the air conditioning unit itself. Remember to always exercise caution when working with electricity. Follow proper lockout-tagout procedures to ensure that the power is disconnected before you begin any work. If you are not qualified or comfortable troubleshooting electrical issues, it's always best to contact a licensed electrician for assistance. They have the training and experience to safely diagnose and repair electrical problems. When examining the air conditioning unit, pay attention to the condition of the condenser fan motor. A failing fan motor can draw excessive current, leading to an overload. Listen for any unusual noises coming from the motor and check for signs of overheating. The capacitor associated with the air conditioning unit's motor should also be checked. A weak or failing capacitor can cause the motor to draw more current than usual, contributing to an overload. A multimeter can be used to test the capacitance of the capacitor. Also, verify that the air filter is clean. A dirty air filter restricts airflow, causing the air conditioning unit to work harder and draw more current. Replace the air filter regularly to maintain optimal performance. Check the refrigerant levels in the air conditioning unit. Low refrigerant levels can cause the unit to operate inefficiently and draw more current. This requires specialized equipment and knowledge, so it's best left to a qualified HVAC technician. Also examine the contactor, which is an electrical switch that controls power to the air conditioning unit. A faulty contactor can cause arcing and voltage drops, leading to a trip breaker. Look for signs of pitting or corrosion on the contactor's contact. If the air conditioning unit has been running for many years, it may simply be nearing the end of its lifespan. Older units tend to become less efficient and more prone to problems, including drawing excessive current. Consider replacing the unit with a newer, more energy-efficient model. When checking the wiring, pay close attention to the wire gauge. The wire gauge must be appropriate for the amperage of the circuit. Using undersized wiring can cause overheating and a trip breaker. Refer to the National Electrical Code, specifically Table 310.15b16 for guidance on proper wire sizing. Also, inspect the breaker panel for any signs of damage or corrosion. A damaged breaker panel can cause all sorts of electrical problems. Make sure that the breakers are properly seated in the panel and that there are no loose connections. If you suspect a problem with the breaker panel, consult a qualified electrician. When measuring the current draw, be sure to measure the current on each leg of the circuit. In a 240-volt circuit, there are two hot legs. You need to measure the current on both legs to get an accurate picture of the total current draw. Also, consider the ambient temperature. On very hot days, the air conditioning unit will have to work harder to cool the space, which can increase its current draw. The breaker's trip curve is affected by temperature, meaning a breaker will trip faster at higher temperatures. When isolating the air conditioning unit, use a multimeter to check for voltage between each wire and ground. This can help you identify any ground faults that may be present. Be extremely careful when working with electricity and always follow proper safety procedures. If you're not comfortable working with electricity, call a qualified electrician. If the air conditioning unit is tripping the breaker frequently, it's important to address the problem promptly. Repeatedly tripping the breaker can damage the breaker itself and can also create a fire hazard. The air conditioning unit start capacitor assists in starting the motor. A failing capacitor can cause the motor to draw a very high inrush current, which can trip the breaker. Testing the capacitor involves using a multimeter to measure its capacitance. The reading should be within the tolerance range specified on the capacitor's label. When checking for loose connections, pay attention to the connections at the breaker, the contactor, and the air conditioning unit itself. Loose connections can create resistance, which generates heat and can cause the breaker to trip. Also, check the condition of the wiring insulation. Damaged insulation can expose bare wires, creating a short circuit or a ground fault. Look for cracks, cuts, or abrasions in the insulation. If you find any damaged insulation, repair or replace the wiring. Check the voltage at the air conditioning unit. Low voltage can cause the unit to draw more current. Use a multimeter to measure the voltage at the air conditioning unit while it's running. It should be within the acceptable range, typically plus or minus 10% of the rated voltage. If the voltage is low, investigate the cause, such as a problem with the utility company's transformer or undersized wiring. Verify that the breaker is properly sized for the air conditioning unit. The breaker should be sized according to the air conditioning unit's nameplate. Using an undersized breaker can cause it to trip even if there's no other problem. Refer to the National Electrical Code for guidance on breaker sizing. If the air conditioning unit is connected to a surge protector, make sure the surge protector is functioning properly. A faulty surge protector can sometimes cause a breaker to trip. Try bypassing the surge protector to see if that resolves the problem. Check the air conditioning unit's fan blades for any obstructions. Debris such as leaves or twigs can restrict airflow and cause the unit to work harder and draw more current. Remove any obstructions and clean the fan blades. If the air conditioning unit has a reversing valve, check to see if it's functioning properly. A faulty reversing valve can cause the unit to operate inefficiently and draw more current. This is best left to a qualified HVAC technician. Also, consider the possibility of a nuisance trip. A nuisance trip occurs when a breaker trips for no apparent reason. This can be caused by a faulty breaker, electromagnetic interference, or other factors. If you suspect a nuisance trip, try replacing the breaker with a new one of the same size and type. If the air conditioning unit is located in a humid environment, check for corrosion on the electrical connections. Corrosion can increase resistance and cause the breaker to trip. Clean any corroded connections with a wire brush and apply a corrosion inhibitor. Ensure that the air conditioning unit is properly grounded. A proper ground provides a safe path for fault current to flow, which helps to prevent electrical shock and fire hazards. Check the grounding conductor and ensure that it's securely connected to the air conditioning unit and the grounding electrode system. If the air conditioning unit is wired with aluminum conductors, make sure that the connections are properly made with antioxidant paste. Aluminum conductors can corrode over time, which can increase resistance and cause the breaker to trip. Use a wire brush to clean the conductors and apply antioxidant paste to prevent corrosion. If you have multiple air conditioning units in your home, consider staggering their start times. This can help to reduce the peak demand on your electrical system and prevent overloads. Use a timer or a smart home system to stagger the start times of the units. If you've tried all of these troubleshooting steps and the air conditioning unit is still tripping the breaker, it's time to call a qualified electrician or HVAC technician. They have the expertise and equipment to diagnose and repair complex electrical problems. Remember that working with electricity can be dangerous. Always follow proper safety procedures, and if you are not comfortable working with electricity, call a qualified professional. When dealing with older electrical panels, like the IT 200 amp panel mentioned, extra caution is warranted. These older panels may have components that are nearing the end of their service life, and they may not have the same safety features as modern panels. If you suspect any problems with the panel itself, such as loose connections, corrosion, or damaged breakers, it's best to have it inspected by a qualified electrician. They can assess the condition of the panel and recommend any necessary repairs or replacements. If you're experiencing frequent breaker trips, it's important to address the underlying cause. Ignoring the problem can lead to more serious electrical issues and potentially create a fire hazard. A thorough inspection and proper repairs are essential to ensure the safety and reliability of your electrical system. Consider having a professional electrician perform a whole house electrical inspection. This can help to identify any potential problems with your electrical system, such as overloaded circuits, loose connections, or outdated wiring. A whole house electrical inspection can provide you with peace of mind and help to prevent future electrical problems. If you're planning any renovations or additions to your home, it's important to consult with a qualified electrician to ensure that your electrical system can handle the increased load. Adding new appliances or fixtures can overload your electrical system and cause breakers to trip. An electrician can assess your electrical needs and recommend any necessary upgrades to your panel or wiring. Remember that electrical codes and regulations vary depending on your location. It's important to comply with all applicable codes and regulations to ensure the safety and legality of your electrical work. Consult with your local building department or a qualified electrician to determine the specific requirements for your area. Consider investing in a surge protection device to protect your electronic equipment from power surges. Power surges can damage sensitive electronic components and cause them to fail prematurely. A surge protection device can help to protect your equipment from these damaging surges. There are different types of surge protection devices available, including whole house surge protectors and point-of-view surge protectors. A whole house surge protector is installed at your electrical panel and provides protection for your entire home. A point-of-view surge protector is plugged into an electrical outlet and provides protection for the equipment that is plugged into it. When selecting a surge protection device, look for one that has a high surge current rating and a low clamping voltage. The surge current rating indicates how much current the device can handle before it fails. The clamping voltage indicates the voltage at which the device will start to divert the surge current. A lower clamping voltage provides better protection for your equipment. Also, make sure that the surge protection device is listed by a recognized testing laboratory such as Underwriters Laboratories or UL. This indicates that the device has been tested and meets certain safety standards. Regularly inspect your electrical outlets and switches for any signs of damage. Look for cracks, chips, or discoloration. If you find any damaged outlets or switches, replace them immediately. Also, make sure that the outlets and switches are properly grounded. Use a multimeter to check the ground connection. A properly grounded outlet or switch should have a resistance of less than 1 ohm between the ground terminal and a known ground point. If you are using extension cords, make sure that they are properly sized for the load that they are carrying. An undersized extension cord can overheat and cause a fire hazard. Refer to the extension cord's label for its amperage rating. The amperage rating should be greater than the total amperage of the appliances that are plugged into it. Also, avoid using extension cords as a permanent wiring solution. If you need to run power to a location on a permanent basis, install a new electrical outlet. When working with electrical wiring, always use the proper tools. This includes wire strippers, pliers, screwdrivers, and a multimeter. Using the wrong tools can damage the wiring and create a safety hazard. Also, make sure that your tools are in good condition and properly insulated. Before working on any electrical circuit, always turn off the power at the breaker panel. This will help to prevent electrical shock. Use a multimeter to verify that the power is off before you begin working. Place a sign on the breaker panel to indicate that someone is working on the circuit. This will help to prevent someone from accidentally turning the power back on while you are working. If you're not comfortable working with electricity, call a qualified electrician. Electrical work can be dangerous and should only be performed by someone who is trained and experienced. A qualified electrician can safely diagnose and repair electrical problems.